Expecting you put it where the sun is, it would unwind to the circle of Jupiter, a monster totally shaky and going to explode. They are among the most observable impacts of radio energy in the entire universe, conveying more energy than a billion suns. Bug Jew, or startling crawly Jew, is a red Goliath star. Assuming you put it where the sun is, it would connect with the circle of Jupiter, monstrous, absolutely inconsistent, and moreover going to explode. When we think about stars, we no doubt imagine irrelevant glinting things in the night sky. Basically, this is how we see them from down here on Earth. Yet, stars are something completely different. As a matter of reality, maybe quite possibly one of the most prominent stars, Betelgeuse, is fundamentally more critical than our sun. For quite a while, this star has perplexed agents. Anyway, truth be told, something additional upsetting has been happening with Bug Jew, making inspectors and other very achieved individuals extraordinarily concerned. Join us in this video as we investigate the grand new data about Bug Jew, its coming obliteration exactly as expected by the James Webb Space Telescope, and how this new advancement will impact our universe and our lives here on Earth. As made sense of by physicist Michio Kaku, Bug Jew is a gigantic marvel, a giant star that has fascinated cosmologists for so long. A Greek space expert named Antonius was the first to find it. This star is so immense that it tends to be viewed in the night sky from Earth, particularly during winter. In the event that you're into cosmology, you've without a doubt seen or caught wind of the star. The becoming flushed orange star means the upper left shoulder of the Orion constellation. So you see, this star is obsolete, and thus far may be one of the most glorious stars in the evening sky. Yet, one thing about frightening little creature Juice's brightness is that it doesn't stay dependable. Rather, it differs. This change is one of the great properties of the star, but it isn't the only one. We ought to explore some of Bug Jew's specific properties. The greater part of the stars you find in the night sky are a long way from Earth. The nearest star is 4.2 light-years from Earth. In case you dismiss how the term light-years gives a sense of distance, picture it this way. Consider moving at the speed of light for a whole year. It's been shown how light can cover a distance of 186,000 miles per second. Thus, the distance light can cover in a year is essentially comparable to 1 light-year. Predicting you crunch the numbers, you'll have billions of miles. So when we say the closest star is 4.2 light-years away, it means it is regardless billions of miles from Earth. Look at this. Some stars are farther, and Bug Jew is one of them. Bug Jew is tracked down around 600 light-years from Earth. So assuming that you somehow wind up going to it at the speed of light, it would in any case require 600 years. We can't move that quick. Not even our speediest space rockets can. However, this star can in any case sparkle so brilliantly in our sky. If you're considering how Bug Jew can be so great regardless of its distance, that is a result of its unique attributes like size and quality. Bug Jew is on numerous occasions more enormous than our sun. Its range is recognized to be commonly that of the sun. Tragically, it shows up as a disk in space while utilizing current telescopes, while various stars show up as nearly nothing places of light. This is accepted to be an impact of the reactions at the external layers of its air. In regards to mass, Bug Jew weighs around 12 to 19 solar masses. A solar mass is the standard unit of mass utilized by space researchers. One solar mass is like 2 by 10 to the power of 30 kilograms. Specialists can't pick the specific mass of Bug Jew since there are no other planetary bodies circling around it to look at it with, and of course we can't gauge it straightforwardly from here on Earth. At any rate, this makes Bug Jew on numerous occasions heavier than our sun. The brightness of Bug Jew goes from size +0 to +1.6. In more undeniable terms, Bug Jew is ordinarily more amazing than our sun. No great treat, it was nicknamed a red giant. At any rate, the quality of Bug Jew doesn't stay solid. It differs. This change is due to its pulsates. In other words, Bug Jew expands and contracts. When it extends, it gets more splendid. At the point when it contracts, it reduces. This cycle can endure for 10 to 100 days, or indeed even significantly longer. A clever property of Bug Jew is that its surface is canvassed in dull, attractive spots. The attractive field here is far more grounded than at the normal surface. Anyway, the drawback is that these strong attractive spots slow down the progression of hot gas to the star's outer surface, making the star cooler in these areas. The reality that Betelgeuse has so many of these spots, contrasted with our Sun, makes sense of why it is cooler than our Sun, notwithstanding its size and splendor. The Sun likewise has its own dim attractive spots, but those on Betelgeuse are a lot larger and altogether more numerous. To give you an idea, the spots on Betelgeuse can be 2 times as broad as Earth. Betelgeuse flaunts an attractive field that is a large number of times more grounded than that of the Sun. This field is the explanation that when seen through a telescope, the gases on the external layer of Betelgeuse appear to be whirling around or twisting. Betelgeuse has a surface temperature of around 3,500 K. This low temperature adds to the low energy discharged by the star and its feeble red variety. Frightening little creature Betelgeuse is a red star, but it wasn't always red. It was yellowish something like a long time ago, like our Sun. Over the long run, the variety started changing to orange, red, and then about 1,000 years ago, it slowly began changing into the red star we know today. This reality has led scientists to believe that the star is developing. Betelgeuse produces as much as several times more energy than the Sun. It would have been a maddened contender to Earth's Sun if it weren't so far away. The way that Betelgeuse, which is 600 light-years away, can still be seen and related with the unaided eye around evening time is incredibly striking. Our Sun is simply 8.3 light-minutes from Earth. That's why it's so strong. If Betelgeuse were just a little closer, we would also be able to see it during the daytime. But if it somehow managed to replace the Sun, it would consume or displace the Earth and the other 4 planets close to it because of its enormous size. Other than whether it were to match the Sun in size, it would still emit more radiation. Betelgeuse, also known as Betelgeuse, is an extremely giant star located in the star group Orion, about 600 light-years from Earth. Its immense size is potentially one of its most striking parts. It is ordinarily more significant than our Sun with respect to its size and could easily include the circle of Jupiter if placed at the center of our solar system. This unbelievable size permits Betelgeuse to show up as a disk instead of a point of light when seen through strong telescopes, not at all like most different stars. Despite its huge size, Betelgeuse isn't the most giant star. Its mass goes from around 12 to 19 times that of the Sun. This variety in mass estimates is due to the difficulties in precisely estimating the mass of stars that lack companion stars or other objects to provide gravitational reference points. In fact, even at its lower estimated mass, Betelgeuse remains a giant heavenly body. The brightness of Betelgeuse is another key characteristic. It varies reliably over time, with its brightness going from magnitude 0 to plus 1.6. For comparison, a magnitude 0 star is about 2.5 times brighter than a magnitude plus 1 star. At its brightest, Betelgeuse can be several times more brilliant than our Sun. This change is ascribed to its pulsates, intermittent extensions and contractions brought about by inside cycles within the star. When Betelgeuse expands, it becomes brighter. When it contracts, it darkens. These pulsates can last for a long time, adding to its dynamic appearance in the night sky. Betelgeuse's surface temperature is relatively low for such a massive star, measuring around 3,500 Kelvin. This gives it a distinct red hue, typical of red giant stars nearing the end of their life cycles. Like other red giants, Betelgeuse is in the late stages of stellar evolution. It has depleted the hydrogen fuel in its core and has begun fusing heavier elements. This fusion process produces energy and causes the star to expand outward. The star's atmosphere is rich in complex physical phenomena, showing dark magnetic spots on its surface, where the magnetic field is stronger than the surrounding areas. These spots prevent the convection of heat, leading to cooler regions on the surface. Despite these cooler spots, Betelgeuse remains a colossal, brilliant star, but it will ultimately meet its end in a glorious cataclysmic explosion. Betelgeuse is a massive star advancing toward the end of its life, and its potential fate will be a dramatic one. When it runs out of fuel, it will undergo an extreme process of fusion, turning heavier elements like helium and carbon. This will cause the star to expand to possibly much greater sizes, making it one of the largest stars in the night sky before it dies in a tremendous blast. A powerful event that marks the death of a massive star. The force of a supernova is strong enough to quickly obliterate an entire system. This phenomenon could even send shock waves through space, and it's possible Betelgeuse will experience such a dramatic end very soon. This fate, while not inevitable, is something researchers are closely studying to learn more about the fate of stars and the evolution of the universe. As Betelgeuse approaches the end of its stellar life, astronomers are paying close attention to its behavior. The star is expected to go supernova in the end, a destructive event that will result in the release of its outer layers into space, leaving behind a dense core. This core could become a neutron star or collapse further into a black hole, depending on its mass. A supernova is a catastrophic event in a star's life cycle, signaling the final stages of its evolution. Betelgeuse's possible supernova could be visible from Earth without the aid of a telescope, given its immense brightness and relative proximity. This explosion would release enormous amounts of energy, creating heavy elements like iron and nickel, which are essential for the formation of planets and other celestial bodies. These elements would be scattered throughout the universe, enriching the interstellar medium and contributing to the creation of future generations of stars and planets. Interestingly, scientists have been able to detect unusual changes in Betelgeuse's brightness recently, leading to speculation that the star could be approaching the edge of a supernova. However, despite these fluctuations, it's difficult to predict exactly when the star will explode. Some researchers have suggested that Betelgeuse could go supernova within the next 100,000 years, a brief period in the life of the universe, but still too far away to pinpoint exactly. The James Webb Space Telescope, JWST, has provided new insights into the star's behavior. Its infrared capabilities allow researchers to study the star's outer layers and magnetic fields in extraordinary detail. JWST findings have confirmed the star's ongoing changes, including its irregular brightness and potential instability. These observations provide crucial data about the processes leading to a star's death, offering a better understanding of stellar evolution. Betelgeuse's demise will have wide implications for the universe. The supernova shockwave could possibly trigger the formation of new stars in the surrounding area, aiding the cycle of stellar birth and death. Additionally, the elements created by the explosion will spread throughout space, contributing to the building blocks of new planetary systems. In the grand scheme of cosmic evolution, the death of Betelgeuse will not only mark the end of one of the largest stars we can observe, but it will also pave the way for the next generation of celestial objects. Despite the fact that we will not be around to witness the star's final moments, the study of Betelgeuse provides valuable insights into the life cycles of stars and the dynamic nature of the universe. The research conducted on this star helps astronomers better understand the processes that govern stellar birth, life, and death, and it offers a glimpse into the fate of other stars with similar characteristics in the future. Scientists hope to continue studying Betelgeuse with the help of cutting-edge technologies and space observatories. The information gathered from the star will continue to shape our understanding of astrophysics, assisting us in unlocking the mysteries of how stars evolve and what their violent deaths mean for the universe. All in all, Betelgeuse, as a massive and dynamic star, is an essential part of the celestial puzzle, and its eventual demise will be one of the most fascinating events in the history of our universe. While Betelgeuse's death is inevitable, it's important to remember that the universe is constantly changing and evolving. As Betelgeuse continues its unpredictable evolution, the study of this massive star has sparked curiosity and concern among astronomers. In the context of stellar life cycles, Betelgeuse is particularly significant because it offers scientists a glimpse into the final stages of a star's life. Most stars, like our Sun, follow a more gradual path, but Betelgeuse is far more volatile. Being in its red giant phase, it has exhausted much of its hydrogen fuel, causing it to expand and cool down. This process is common in massive stars as they prepare for their inevitable end. However, Betelgeuse's fate remains uncertain. Unlike our Sun, which will end its life in a less dramatic way, transforming into a white dwarf, Betelgeuse will undergo a much more violent death. The supernova explosion will mark the end of its stellar life, releasing an enormous burst of energy that could outshine the entire galaxy. When the star eventually collapses, it may form a neutron star or even collapse into a black hole, depending on the remaining mass. The end of Betelgeuse will be one of the most spectacular cosmic events, and while we are far from fully understanding its timeline, its eventual demise will undoubtedly leave an indelible mark on the universe. In addition to its intrinsic interest in astrophysics, Betelgeuse also plays an essential role in enriching the cosmic environment. The explosion of massive stars like Betelgeuse spreads elements that are crucial for the formation of new stars, planets, and even life itself. The carbon, oxygen, and iron produced in the explosion will be scattered across vast distances, contributing to the molecular clouds that give rise to future generations of celestial bodies.